Our next presenter is Keith Conway. He's with Northrop Grumman. He's our DevOps Cyber Architect. He's going to be presenting on injecting cybersecurity into DevOps. So take it away, Keith.
Thanks, Juan. And I want to thank David. That last presentation was excellent. Is my screen currently in presentation mode?
It is not. It was earlier. A few seconds ago.
There we go.
There we go.
Okay. So I have about 25 slides. So a minute or two per slide. So hopefully this will be a pretty fun presentation. I have a few concepts to cover. I am a software engineer. That's my background, around 20 years, Java, C#, service-oriented architecture. And then recently, maybe in the last 7 years, I got into cyber. I have a few cyber certifications. I feel like the software and the cyber go hand in hand. So kind of, I have a diverse background, so I can talk to a whole bunch of different people. Maybe not good at anything, but I know a little bit about a lot type of deal. Okay, so this presentation, the title has cyber in it, and it's talking about injection points. Now, cyber is a very generic term, and cyber means something different to everybody. So my point there is a software engineer is going to think about cyber different than a hardware engineer versus a network engineer. So really, I'm just talking about generic cyber points today. And I have a pretty good role. So part of my job is to develop best practices that can be used by new programs or potentially on proposals and also incorporating into existing programs. This slide deck has been in the making for the last 6 months. This is my second time presenting it. I probably have around 5 different main areas. I have pictures, I have text, all of it's really basic, which I love the fact that it's pretty simple to follow. But once again, I think it's very difficult to achieve, but as long as we all have an understanding, it'll really help. So this is I like it, the colors and the flow for a DevOps pipeline. And I have some numbers in red, 1, 2, 3, 4, 5, 6, which relate to the text on the left. The very first part, we talk about security as code, and we're going to get into unit testing. The second part, the SAST, we are actually going to be talking about code quality, static code analysis. We'll get into our build image, which is very interesting because we can take a hardened image through development, integration, and deploy it. So then we'll get into deploy staging, end-to-end test, and then finally release. This picture, you know, each one of these badges that you can follow along the outside of the infinity is a place where you can inject security. But we're only going to talk about the left-hand side in development. The operational side on the right-hand side is a different discussion. Still pretty interesting. So we'll get into the automated unit test, and I I know that David brought this up as well. And the bottom bullet shows, hey, 80% code coverage is a good goal to aim for. I just had a conversation with one of our other architects and talked about this being more of a code quality versus cyber. And I feel that is a very good point, which I am hoping to cover. And even if you look at this paragraph in here, it talks about a program having higher test coverage has more of its source code executed during testing, which suggests it has a lower chance of containing undetected bugs, such as quality. Then we get into just a basic definition of unit tests, and it says that they are low level and tested in isolation. And unit tests are typically written by developers themselves. Now, this is where it gets really good, and this is why I am a fan of injecting cyber into unit tests, because we can talk about input validation. Now, input validation at a very low level, when we are talking about at a function, a method that inputs, that really is a key area for cyber right now, is we just have to sanitize our inputs. We have to know that when we are receiving data, the data is valid and not going to have dangerous information associated with it. So the boundary is extremely important as well, and unexpected conditions. My whole thought and the whole rationale is for these automated unit tests to have input validation. Now, once again, this presentation is injecting cyber into DevSecOps. So that's why, from my point of view, when I speak with software programs about input validation, that is really the cyber focus. I'm not, sorry about that. I am not as interested in the 80% versus 20% code coverage. I'm interested in input validation specifically, and to make sure that these programs know how important input validation is. This is the OWASP top 10, and 4 of the OWASP top 10 all relate to input validation. The number 1 on the OWASP top 10 is injection, which is where a bad actor is injecting malicious code into the application. And the whole goal in general of a bad actor penetration tester is to receive a reverse shell and to have access to your system. And they are injecting a shell, whether it be a buffer overflow or another type of a shell, such as Python, Java, but they are injecting code trying to receive a reverse shell. So this is showing that we have the number 1, the number 4, XML external entity is also where they are injecting bad code into the XML. And when the server receives this XML external entity, it executes the bad XML and it provides the reverse shell. Same with cross-site scripting. And then when you are deserializing the code, if you just blindly deserialize it, there could be some bad code that you are deserializing and potentially executing for the reverse shell. So the main point here, I feel, is extremely straightforward. Input validation has to be part of our automated unit test. Software engineers have to know how important their role is in cyber and how important input validation can be to the overall hygiene of not just the software, but the application itself. Big wins on this one. Okay, so now moving on to the second part. If you look at the bottom left-hand corner, I have the red number 2 next to SAST. When I talk about SAST, I'm really talking about static code analysis. And a few years ago, I've been working with SonarQube, and SonarQube has a really cool stop the leak documentation. And if you look at the picture on the bottom right-hand corner, it shows a bathroom, and the bathroom is full of water. So if you come home and your bathroom is flooding, are you going to pull out a mop and a bucket and start cleaning up the water, or are you going to try to find out where the leak is coming from and stop the leak first? So SonarQube, the stop the leak, the high level overview is telling you that, hey, you need to stop rule violating code from being checked into the repository. Once you have stopped the rule violating code from being checked in the repository, at that point you can start fixing code if you choose to. But the first goal has to be stopping the rule violating code from being checked in. Now, there's a couple ways that we can do that. We can set up security gates, or we can also set up the peer review. And I know David brought up the peer review being part of a pull request as well. Just to expand on the stop the leak analogy, so looking at the bottom right picture, all the water on the floor could be the rules, the rule violating code that's already in your repository. So like it or not, you can always have rule violating code in your repository. And the reason I say you can always have rule violating code in your repository is because a new rule could be generated which was not run on previous iterations of the code. So anytime you have a new rule set, you could potentially have rule violating code. So the whole idea is you already have rule violating code in your repo. So let's stop new rule violating code from being checked in. So this is just a basic picture where it talks as you're going from top to bottom. It just talks about from master, hot fix, release. Develop is really where I am focused, and it shows a big red arrow pointing. So the feature branches in blue at the bottom would be where a developer is working. And so the common term is check in early, check in often. The reason for that is we don't want code living on a developer's workstation. If anything goes wrong with their development workstation, we lose the code. So we want to check the code in to make sure that that code is safe. The area that we are interested in is that when a developer's code is going to get checked into a branch that can be shared with other engineers. Because once the code is checked in and other engineers start using it, the code can go to different branches and it spirals. So really what we are trying to do with rule violating code is to stop the code from being merged into an area where the code is shared with the rest of the team. So this is showing from the blue to the orange, we're going to let the developer check code into their own branch, which is an isolated branch only shared with themselves. Now, we are most interested in when the code is getting checked in, and this is where we can set up either the quality gate or the peer review. So the two ways that we are going to stop this rule violating code from being checked in is the quality gate, which is an automated way. Now, remember, anytime you have something automated, it can also cause issues because static code analysis tools, whether we're talking Fortify or Coverity, SonarQube, Clockwork, there's many of them. There's plenty of false positives. And if we set up a automated way to stop rule violating code from being checked in, you are definitely going to be slowing down development time, which some may think is a good thing. But when you are at the end of your agile sprint and your code is due and you can't check in because of a false positive, at that point you're not happy. I don't really aim to make people happy with my role. I just want to make sure that if we have rules, that the rules are followed. So once again, quality gates are a way to stop rule violating code from being checked in. And a second way is to actually go through a peer review. And the peer review is where the software development team will actually review the code to allow or not allow the code to be checked in. Ideally is the static code analysis report for the code that is being checked in would be part of the peer review, where you can cover the findings, whether they're Cat 1 criticals or from Fortify or blockers from SonarQube. The static code analysis report will be part of the peer review, and you can determine whether it is a false positive or not and allow the code to be checked in. Okay, just another picture of water leaking out. And once again, do you try to fix or clean up the water, or are you trying to stop the bad rule violating code from being checked in? And my last part that I want to say on this is that the static code analysis rule sets are configurable and they can be tuned to your system. Now, the rule set, they take time to configure, but it does make for code that you are comfortable with in your repository. Okay, moving on to the third part, and this is where we are talking about a hardened image to be used through development, integration, and finally to operations. This is a very fun area, and it is a concept that the many different people are very interested in right now. Okay, so I know that David covered this already, so we're getting a double dose of it this morning. And in the top right, we have this concept of pets versus cattle. One you own and one you don't. It's just a number and it's interchangeable. I definitely am a fan of this environmental drift, and it's just showing that you are trying to maintain the environmental configuration. Once your environmental drift starts to happen, you can become a snowflake, which is a unique configuration. And this unique configuration is extremely difficult to administer and maintain. And you have experts just for your unique configuration to maintain it versus a generic. Now, the opposite is idempotency. And that's the process that your configuration can be set to a baseline with the click of a button. Now, there's many aspects involved in getting back to a baseline configuration or an idempotent configuration. Some of the main parts that we're talking about is installation scripts for the software that is going to be running on that operating system, whether it's a VM or a container. So this is getting back to the pets versus cattle. And as long as we know that with the click of a button, we can reinstall a system, once again, whether it's bare metal, a virtual machine, or a container, we can reinstall via automated installation scripts the applications onto it. We can move away from the environmental drift or the snowflake and go back to a idempotent state or a state of configuration management. I'm definitely not saying that drift is something that you can always avoid. A lot of times we have to make changes to a system. The area that I'm saying is that if you are going to make changes to a system and you're going to drift, those changes should become part of the configuration. So the next time you perform an update, those changes from the drift are part of the configuration management, and now you're back in a state of idempotency, which is what we want, consistency. This is just showing the level of risk that a program is willing to take, and that depends on, showing minimum to maximum risk, and that will decide what your hardening of your operating system is going to be. Once again, bare metal, VM, or container. So this picture I like quite a bit, and it's showing the flow and going from on the right hand side from development, integration, and then cloud and release can be the same. I broke them out, and if you look at the circle in the middle, it's a repeated process. Now, if we have a new hardened virtual machine, once again, it can be a VM, a container, or just bare metal. We could get updated, hardened operating systems, whatever the schedule may be, between a 7-day and a 90-day window. And as long as we have an automated script to install and configure the service, it doesn't matter what our update schedule is for the hardened operating system, because we can just click the button and we can go back to a state of configuration management. And this is the snowflake versus the idempotency. Looking at the picture on the top right, so our pets, when they get ill, you have to do some work to fix them, which would be the snowflake configuration. If a virtual machine or container goes down, someone has to go out there and look at it and perform the work to fix it. Now, on the opposite side, as far as cattle, if your container is damaged or virus or something goes wrong with it, you can just swap it out with your automated scripts and install a new one. So definitely a huge fan of this whole concept of pets versus cattle in automated installation scripts to go back to the state of idempotency. So I wrote down some pros and cons here between the pets versus cattle, and one of the big areas that I thought was a pro and a con, I put a red star in there. They both say the same thing: is no ownership of machine. So it can be changed out when a new configuration managed operating system is generated. So the reason I put the star next to both of them is for the fact that drift is going to happen at an operational site. It's a fact of life. And actually, I think drift is something that we just have to go with. The part that is the more difficult concept is the fact that once you perform the configuration updates, which is, in my mind, as long as a board accepts it, it allows everyone to keep moving forward. The problem now occurs is that you have to update that baseline configuration. So the next time you perform a system update, those changes that once were environmental drift are now part of that baseline configuration. So it could slow down the process to update and to make sure everything is configuration managed. But in the long run, you are going to be saving so much time because you are moving away from a snowflake or this unique configuration, and now everything is consistent, and you can, if a major security breach occurs, you can, whatever hardening has to happen to the operating systems, and then you can roll out a whole new system, which is configuration managed, and you have no issues. So I'm definitely a fan of this part. Okay, so now we're getting into the specific development part, where if the hardened operating system is used, the same hardened operating system is used from development through integration through operations, the development team can create the automated installation script during development. So the build can occur and the development team can install that build via an automated installation script onto the same hardened, whether it's a VM, container, operating system, to make sure that the automated installation script works properly against the same operating system that will be used from development through integration through operations. So if you look at the bottom, I don't really get super involved in what type of scripting language a group wants to use. You know, every program is different, but the deal is you should go with some sort of installation script to install the application onto the hardened operating system, which is available from development through integration through operations. So now moving to the integration stage, this is where it gets a little bit closer to operations. And now the development team is no longer in control of that hardened operating system. And the installation script that the development team created is used to install the application on the VM container or bare metal, just the operating system. So now the development team is out of control, just their script is being used. And this lets you know during integration if your script is valid or not, right? So you definitely want to catch this during integration, which is going to lead into the operations. So the big point is the very bottom sentence. The software build and automated scripts are supplied. The hardened VM needs to be part of the integration server, not owned by the software development team. So the software development team is no longer touching this part. This is definitely an integration part. Okay, so end-to-end test. This is a very interesting area. So if we think about number one, we were talking about automated unit tests, and we talked about input validation. When we looked at SAST, number two, static code analysis, we were talking about rule. What happened? Sorry about that if I did that. Sorry about that, guys. The end-to-end test. So when we talk about end-to-end test during integration, this is an area that you can actually have security requirements being covered. Now, most people would not think of end-to-end test as where you attach a security requirement, and that is the whole concept of this presentation, is to say, look, this is a perfect area for an automated security requirement to be tested via automation. For instance, you could have a specific button on an application that you have to be part of a specific role to click that button, and that could be tested during this section. It is a perfect area to test security requirements. Most people would think of all the other requirements that need to be tested during this phase. It is a perfect spot for cyber. Okay, I know my time is kind of moving on, so this one is talking about application security verification standard. And I put in red here that architecture is not implementation, but a way of thinking about a problem that has many different answers. You know, if you look at the sentences below it, most people say, hey, there's a very specific way to fix the code and to solve the problem. And we just have to kind of make sure, as far as cyber goes, we think outside the box. I showed you two areas today as far as automated unit tests and input validation. I think we all know about static code analysis. We all know about hardened containers. But another area we talked about was the end-to-end test, and that's where we could go over security requirements. And then I'm showing a little bit about just the basics of sound security architecture. And I believe finally is the release to operations. And this number 6 is an artifact of the making it through the integration of 4, where our automated installation script installed the application on top of the hardened virtual machine, which is going to be used out at operations. So I definitely feel that if you look at number 3, number 4, and number 6, they're all using the same hardened operating system. And as our hardened operating systems change, it means that the development team might have to make some updates to the script in order for the software to work. And that is part of development and maintaining software, to make sure our cyber hygiene is the best it can possibly be. And that is it.
All right. Thank you, Keith.
Thank you, guys.
For anyone in the audience that has any questions, please feel free to ask them in the question panel. By the way, we did receive a question comment earlier, Keith, when you were going through the first-time quality metrics or the first-time quality gates. It says first-time quality must go hand in hand with clean up the current code.
Would you say that one more time?
First-time quality must go hand in hand with cleaning up the current code. It was more of a comment than a question.
Okay, so I think it's a very valid comment. So an area, and I'm not going to say right or wrong, but anytime you're touching code that is already in your code base, you have a potential, if you fix one problem, you break something else. So my biggest area right now that I think about all the time is we need to stop rule violating code from being checked in. And, that gets back to the whole stop the leak. So I'm definitely a fan of first time quality, and I do understand the theory of everything needs to be perfect. So we just have to, we should start in a phased approach and make sure that we stop the rule violating code from being checked in. Then at that point, we can start looking at existing code. And I think the one of the points that I made was pretty important, and I've thought about this quite a bit, is these rules are configurable. The rules change every year. They need to change every year. So if our rules are always changing, there's no way that you can say that your existing code repository is error-free, because you don't know what errors are going to show up in a year from now. So that's why it's, I do agree with the first-time quality, but it's very involved.
There's another comment. The definition of upgrade, the exchange of old bugs for new bugs.
I'm not sure if I understood.
Because when we're talking about doing upgrades, we're exchanging old bugs with new bugs or introducing new bugs.
So with an upgrade, I was thinking of the operating systems or VMs or containers. So I'm not sure I still understand the upgrade.
Okay. Is there any further questions for Keith?
I would like to say in closing that I really enjoyed speaking with everyone. I'm very excited / interested / want to speak about cyber. I think it's very difficult as you start getting into it, but it's also very satisfying to know that you are helping. And this doesn't have to be the craziest cyber initiative for your program or your company. You can start small. Input validation, it's super important. And then also just with your static code analysis, just looking at your rule set and stopping rule violating code from being checked in, just really at a small level. And then even when you're stopping rule violating code from being checked in, You know, they have the whole concept of high, medium, or low, or Cat 1 critical, Cat 1 high, or blocker critical high. You know, you can start off small and just say, hey, we're only going to stop the most extreme cases in the beginning, but at least it is a starting point. So you have to start somewhere, and this is what we want. We need to start making moves in the right direction.